Welcome to another session of Lightblade Learning Lab. Today we're going to do a complete project. We're going to start off with a drawing that I have already created in another program, and as I've already mentioned to you, this program RDWorks is not a CAD program. It's not a drawing program, it's an interface program. So you will need to do your design work elsewhere and then import your file. Now I've imported my file here. A series of parts which when we look at them we'll see that they've got outside shapes, they've got holes in them, and we've got some text. Now this text was created in my CAD program and it's been specially created as a single line text. I purposely haven't used the sort of text that you would normally think of, which has got some width to it and some character to it. The reason I've done that is because I want to keep this session as simple as possible, and we can actually cut this text as opposed to engraving it or etching it. Now engraving is a subject all on its own which we will tackle in another session. So I'm not wanting to complicate this session too much because we've got enough to deal with anyway. We're going to be cutting the text and we're going to be cutting the outside and the shapes, but we don't want the text to go right the way through. So we've got to use a different power, a different speed. We've got to process the text differently to the rest of the items on this page. To do that, we're going to have to put it onto a different layer. Let's go through how we do that to start with. First of all, we will remove the handles that happen to be defaulted when you import it. And now we need to mark this text. Now, you need to be very careful because we've got to put a little marquee round each piece of it on its own. So we've got Lightblade there, and you'll notice that it's turned red. That's fine. That means we've captured it. Now we must press the Shift key on the keyboard without catching any other complete object, and you'll see that I can start off outside the outside shape, steer clear of the hole. I can go across, steer clear of that hole on the right hand side, and steer clear of these little slots at the bottom, and I can collect that one as well. So now I've added all of these pieces together into a little group. We haven't actually defined them as a group, but they have just been marked as a group. We will now go down to the bottom left hand corner here and we will select any one of these colors, but let's just check that select the blue layer because we've already got a black layer on the page. Okay, so now our text has become blue, and you will notice up at the top right hand corner here we've got a blue layer that's been added. Let's just take a quick look at that blue layer by double clicking on the blue patch. Okay, so how do we go about selecting the speed and the power? Well, that all comes down to experience in a way. Thinklaser have supplied you with a little memory stick with this machine. Now I earnestly suggest that you go in and take a look at that memory stick because you'll find some data on there referring to speeds and feeds for your machine. They will be typical, but they're at least a start. I've got some experience which I will call upon and point out to you one or two things. First of all, we're cutting small characters. Remember the background grid on this picture is only 5mm. So that means these characters are only 3mm tall. Now, how fast can the machine accelerate? Can it get up to 100mm a second and back down to nothing in 3mm? I doubt it. So the chances are these characters are going to be speed controlled by the machine itself, not by you. So even if you put 500mm a second in there, it's going to make no difference at all to the speed at which these letters are going to be cut. So you may as well plonk something reasonable in there. 100mm a second is still unlikely to be achieved by the machine, but we don't want the machine to cut all the way through. So we need to keep the speed fast so that it stays as fast as the machine can go. The next issue is the power. We're going to be using 3mm thick acrylic to do this job, and even if we were to apply maximum power, the full 60 watts of my machine, we would not be able to cut through this material at 100mm a second. So therefore it really doesn't matter. but what we're going to do is back the power right down to something like 30%, so that we can make sure that we scratch the surface rather than go deeply in. And now we'll go to the black layer, which is the cutting layer, and we've got to choose some parameters for cutting. Well, as I did mention to you, we're using 3mm acrylic on this job. From experience, I would know that cutting 3mm acrylic with probably a 1.5-inch lens, which is quite a powerful cutting lens, I would be able to probably get up to maybe 20, maybe even 25mm a second. But we're going to be using a 2.5-inch, maybe 2-inch lens, which means that its power density is less. That's a completely different subject, but it does mean to say that I'm going to choose a very conservative number here, and I think 12, probably 12 is okay, maybe even 10. Let's settle with 12. We can always check it out on the machine. If we get it wrong, we can modify the parameters on the machine. And power, well, we want the power at its maximum. Now, you may remember that in a previous session we established that the maximum power that I can use with my 60-watt tube on this machine is 67%. If I run any more than that, I will be overdriving the tube and shortening its life. I'm just being a good boy and I'm sticking to the 67%. Cutting, yes. Blowing, yes. Output, yes. Job done. When we cut the first program, we used the honeycomb bed. Now, I'm going to use a slightly different approach this time, and it means the parts are going to physically drop out. It's a good way to remember that you must ensure that you do your engraving or your cutting first. You must do your holes first before you cut your outside shapes, because once the part has been cut, it will fall out and you've got no chance of coming back to cut your holes. So cut your holes before you cut your outside shape. So that does mean to say that we've got to put some logic into the way that we order the cuts, the processes. And we talked about how you would do that in a previous session. And we looked at this thing here called handle. And we had something called cut optimize, if you remember. We would have order of layer, and then we would cut inside to outside. Now, order of layer meant that we could do the blue layer first, and then we could do the black layer second, which is fine. But then we had a further control within the black layer which said that we could cut inside to outside on single objects. So that meant that we would cut all the holes before we cut the outside shape, all the holes before we cut the outside shape, which was perfect. That's exactly what we wanted. Start cut optimize, start point optimize, well, yeah, you can have it or not have it. It really isn't a big issue with a small job like this. So we could say, okay, let's see what we've just created before we go anywhere near the machine. We'll go to the preview screen, we'll do a simulation, we'll put that to half speed so that we can watch it working. And sure enough, it's going to create the text first. We can now speed it up because we don't want to sit around here too long. Oh, it's doing some outside shapes now. That's fine. Now it's doing some holes first. And then it's going to, yes, it does do the outside shape. So it's behaving itself well. We could say at that stage, let's go to the machine. That process works most of the time. I've come across quite a few drawings where, despite setting those features, it doesn't behave in the way in which you would predict. And so consequently, I don't rely on cut optimize at all. I remove these features. I untick every box in here, and I'm happy to leave that as a nothing box. And I come down here to the right hand corner, and there's something down here called path optimize. Now, that could be ticked by default. Make sure you untick it. Okay, so now I've got complete control over how I want these pieces cut. Okay, so what's the alternative? Well, there's a very powerful alternative that we can use, and that's a feature up here called Edit Cut Property. Click on that, and we open up this lovely box. Let's just move that out the way a minute, because what we've got here is every single element on this drawing has got its own cutting command, and the order in which it's cut is defined by this list. Let's just take a look, for example, at that outside shape there, which I've just highlighted. Oh look, there it is, very conveniently on this list. It's item 20. What about the holes? That hole there, that's item 19. Okay, so that means that hole will be cut before the outside shape. But hey, we don't want to go around and order. Let's have a look how many items we've got on this list. We've got 100 elements on this list. That's a hell of a lot of items to rearrange in the order in which we want them arranged. We're not going to do that. We are going to use this edit cut property box, but before we start going in there, what we're going to do is we're going to organize ourselves into a much smaller group of parts, and the key word in that sentence was group. Let me just explain. We're going to first of all pick up these 4 holes across the bottom here, for example, and we've put them into a little selected group. Now we're going to change them into a real group, and I keep reinforcing the word group because it's a very powerful word. So we'll go up here to this command and we click group. So now if we look, I can click on this one item here and it will mark the whole of the group. So I've got to be a little bit smarter with my marquee this time, because what I'm going to do, I'm going to use my marquee to select just 4 of those external shapes, but I haven't selected the complete group of holes, and so consequently the group of holes remains black, but the outside shapes have gone red. I'm now going to press down my shift key, and it doesn't matter. I could, for instance, come back to here and I could now select. Doesn't matter that I'm reselecting the red group, but what I haven't done is selected the whole of the black group. And now I've managed to capture the whole of the group that I wanted, which is the external shapes along the bottom there. And I'm going to put those into a group. Now if I'd have been smart about it, when I selected these parts to go onto this blue layer, at the same time I would have also put them into a group. Now I didn't want to preempt this grouping technique at that early stage, but just remember, when you're selecting parts for a layer, it's very good to group them as well so that you've already got that job done. So let's go back and select my blue parts, shift key down, check that they're all red, and we'll put them into a group. Job done. Okay, now I need to select the holes on this part as a group. I could start at the top here with my marquee, and I could drag it right towards the bottom here, and I've captured the L of Lightblade as well. So if I leave the L out, I should just capture the holes, which I have done. Shift key down and we'll capture the rest of the holes. So we've put all the holes on that pattern there as a group. Click group. Now I don't have to worry about the outside shape at the moment because we're not going to put that into a group. So now we can put this group of holes here into a group. And there we'll capture very carefully with our marquee, not capturing the outside shape, the holes for that group. And the same for that group. I could have captured all of those holes and put them into a group. Not a good idea generally. In this instance, I don't think it would have made any difference at all, because it's a very small project. But in general, try and cut your outside shape as soon as you've cut your holes. That way you will have no misregistration possibility between the outside shape and your holes. If I move If I do this pattern here and then move off and do all sorts of other things, there's always a risk, a very low risk, but there's always a risk that by the time I come back to cut this shape, the holes may well have moved very slightly. Most of the time it doesn't matter, but on certain key jobs like this one, it would matter. So as a general practice, I would advise cut the holes first and immediately cut your outside shape. Right, now that we've done our grouping process, let's go and have a look, see what effect it's had on our cut list. Edit cut property. Well, there we go. From 100 elements, we're now down to 11 elements. That's a much more manageable list for us to edit. So we will start off by clicking on the part that we want to run first, which are the holes, and you'll notice that they've highlighted. And we can see in this list that's element number 5. We don't need to click on that because it's already highlighted for us. We can just go to the double arrows at the top of the list and do click, and it will transfer that item to a new list as number 1 in the list. And then we'll do the outside shape, click. Then we'll do the text here, click. Then we'll do the holes, click. Outside shape, make sure you highlight the outside shape. Then we'll get the holes highlight. Outside shape, missed it. Outside shape. Holes. Outside shape. Holes. Outside shape. And there we go. There's our well ordered list. So we can now say OK. And to be honest, once you've organized that list like that, you don't ever need to go up here to preview again, because you can be totally confident that the machine will do what you want it to do. We'll just go and have a look to prove the point I'm making. The simulation will be perfect, trust me. Holes, outside shapes along the bottom, text next, holes next, outside shape, inside holes, outside shape, and an outside shape. At the moment we're still programming remotely. We're not on the machine. If we were on the machine we would be doing a download. But because we're not on the machine, we're saving the file to a memory stick. So we need to go to Save to U file. I would advise you, as a general practice, go here first, File, Save As. Now if you've started on a very complicated program, I would suggest that you go and save as at a very early stage, and we'll save this as beamref. Now this gets saved as a .rld file, which means that it is readable by RDWorks again and again. Whereas when we go to save to U file, what it does, it creates a machine code program which you cannot open and you cannot read. So don't try and open an RD file in here because you won't succeed. Although RDWorks is fairly bulletproof, there are times when you can get it to crash. And if you're partway through your programming, and it may be a big program, and the program crashes, you are going to be a little bit frustrated. Now, you'll notice how I've just zoomed out there with my scroll. If we take a look up at the top left-hand corner, we shall find that this is v8.01.18. That's issue 18. There have been lots of issues of this program, and something which has been fixed and hasn't been fixed. And if I scroll out far enough, completely, oh, I can't scroll back again. Program has crashed. Close the program. That's the only choice we've got. So if we haven't saved, we're going to be a bit upset. Fortunately, we saved it before we crashed it. So I can now open this file as beam reference. This honeycomb bed, it's better than I expected it to be. but it's still got some problems which I foresee for the future, and I don't want to make this bed sticky. One of the problems with acrylic is it tends to produce a watery residue, a bit like steam, that condenses into a sticky goo around the place. It can go into your filters, it can go into here, and it would make this sticky, which further attracts dust. I use a steel plate. Now the steel plate has got several advantages. First of all, on here, look, I can stick some magnets, so we can put the supports right on the corner, so that they're not likely to be cut, or we don't have to worry about it. And we'll just check where that one goes in relation to the program, but I think it's going to be clear of the program. And as it's working, I will explain why I've done that. So it's about 10 or 12 millimeters clearance underneath there. Now, I'm going to make sure that the magnets are sitting in the corner somewhere away from the work itself, in other words where I'm going to cut the program. But I think I'll put one in the middle there. Yep, that's quite nicely supported there. First task, autofocus. So we will drive onto the job, check that we're fully up with our head. Okay, so it's not making the autofocus sensor. What that means is we've got to gently drop the probe down, and so it just about, but not quite, touches the surface. We just touch it and lift it off. And now we press autofocus again. Job done. Right, now the other thing that I'm going to do is to ask you to look carefully at the flow of the smoke that's coming out underneath, the fumes. Because what I'm going to do, at the moment I'm running this machine with the lid open. What I'm going to do is to close the lid, and we're going to look at the difference between the airflow with the lid open and the lid closed. So I'm going to turn the extraction system on, start the program. You can see the smoke puffing away and being drawn nicely out the back of the machine, but I suspect that's going to get a lot better. I think it proves the point. The airflow is actually better with the lid open. It's just the airflow is being strangled by the holes in the lid. With the lid closed, the fumes were eddying up in the case. They're not eddying up here. But if you notice the fumes underneath, okay, so there's the job cut. Quite often when you're cutting acrylic, you will get a watery residue left on the surface here. And it's very sticky. In fact, there is just a hint of it there. Although on this occasion, I've not created the sticky, it's a little bit, but I haven't created the sticky goo that often happens when I'm cutting acrylic. But what I'd normally do is I would use then acetone to, oh yes, it's definitely sticky. I can feel this dragging. I would use acetone to clean that off, but recently somebody said to me, why use a dangerous chemical when all you really need is white vinegar? And that does a superb job My argument really is, if it's condensing on here and I can wipe it away, it's not going down into the machine or into the extraction system. Now there is one more obvious advantage, it's a housekeeping advantage over using the honeycomb bed, and that is this. All our pieces now with the film stripped off, we're going to need an assortment of parts which I will describe as we go along, but there will also be a listing of this probably on the Thinklaser website. Now the one thing that won't be defined is this. Now I defy anybody to say they haven't got at least half a dozen of these click pens around in their drawer that either don't work or that they don't need. Well, now you've got a use for them, because inside here is a valuable resource, and there it is. We shall need 2 of those springs. If you can find a matching pair, brilliant. If they don't match, don't get too upset. Okay, now the first item we're going to pick up is the this one with all the big holes in the middle. And if you look carefully, you'll see that around about 10 o'clock here, we've got a little hole, 3mm hole. Now, we need to pick up this piece as well. And again, you'll find that you cannot put this one on and match the holes up unless you put it on the right way. So that sits in front of there, like that. And then you can turn them over, one of those and then 2 of these. Okay, now at the moment I've got my hole down here at about 5 o'clock or 6 o'clock. Slide this piece off for a moment, and we're going to put the one with the hexagon on in front of the one with the hole in. And then we're going to put those tongues into that hole there, so that the hexagon is facing this centre hole. And then we're going to take this piece and we're going to drop it over there, like that, and that should sit in there, and that should all lock in there nicely now, like a little corner reference angle. Now we're going to do exactly the opposite over this corner here. This little piece here will drop over and cross-lap with that one and plug into that. Match up the hole in here with the hole in here, and we're going to slip this one over the top. And technically it doesn't need gluing at all, because everything is nice and snug in there, but I would advise you to glue it. We're going to use this Bondrite cement again, which technically, as I keep telling you, should be acrylic cement, but this is PETG weld cement, which will perform satisfactorily on acrylic. A few drops in the bottom of that bottle, that's enough to do the job. Now I would suggest whenever you're using this stuff, you do it over or on a piece of kitchen towel, because it is quite aggressive to surfaces, and also you don't really want it running anywhere. So it does, if there's any excess goes through to the other side, it will automatically soak up in here. Now the light may or may not be right for you to see this, but when I pop that in there and tip it up, I should be able to get a little bead to run down there, and I'll get a little bead to run down there as well, and one down here, and one down here. Now I can feel that it's already run through the back onto my fingers, so I'll just wipe the back off. The next piece involves these little llamas. They look like llamas or reindeers. And if you look carefully, you'll see that 3 of them have got noses, and 1 of them doesn't. So the one that doesn't have a nose on it, pop it to a side for a minute. Now if you can read that text, then round about here at about 8 o'clock time, you'll see there's a small hole. There should be a matching hole in the disc, so you should be able to line them up. But the reason why I'm asking you to do this is because these have got to go on the back of this. So we turn it over, and one of those with the nose on, we're going to have to very carefully try and get it through both thicknesses. Now that could be quite stiff. We're not relying on anything other than friction to hold this together. So if it's not a snug fit, then realistically we've got to go back and we've got to remake these holes here to make this a snug fit. Now that's a completely different design exercise which I need to go through with you at some future date, how you're going to design parts to fit, because it depends on the lens that you're using and various other things about the material that you're using, the fit that you're going to get. Now what we need is this little thing here. Now this is only a few pence off of eBay, and it is in fact a laser diode. So put your cable through the hole to start with, and then very gently, because these cables here are delicate, that should sit snugly between the reindeers. The nose of the reindeer should fit in a slot that's round here, and that will lock that in place. So this needs to be pushed in. Make sure you've got the noses of all of the reindeers pushed in. Then we need the reindeer or the llama without the nose on as the last one. Now before you put that one in, if you take a look, you'll see there's a little circuit board on there. Make sure that that circuit board is not projecting anywhere to get in the way of the llamas. That should be sitting somewhere between the llamas. If these little pegs are sufficiently snug in these holes, this should be completely solid in here and not rock around at all. Now if you really need to, you can glue the bottom there, and you could even put a blob of glue down against the laser diode as well. The point is the diode must not move. It's got to be rock solid. Now in normal engineering circumstances, I would suggest you drill where we put the hole through there, and I would physically be putting a tap through there. But understanding that probably most of you guys might not have tapping facilities, what I've done, I've arranged to put a nut in there instead for a tapped hole. Okay, so we put a nut in there, and we put one of these long 1-inch plastic screws through there. But make sure that it doesn't stick out above this surface. With the 2 screws at the top and the Lightblade description sitting the right way round, you will see that this little piece at the back here, if you look carefully, you'll see that it's radiused, it's curved, and it sits in these little slots here. And if you rock it around, you'll find that it rocks around very easily in 2 planes. Now the idea of that mechanism is that the front face of the LED always remains in the same position in space. It's the back end of the LED which is swinging around, not the front end. Now the next part of the assembly, I need you to make sure they go together like this, with the holes lining up with each other. And before you start using these springs, which we've cut down, so they're probably about 15 mil long, the springs, but then I want you to get hold of the end of the spring where you've cut it and physically just bend it out. Like that. Can you see that? So that it sticks out about 3 millimeters. Now the reason you're doing that is because the spring will actually fit down and jam inside the hole, and we don't want that to happen. At 3 o'clock we're going to put an M3 screw through, and then we're going to put the spring on with its tail against the plastic, and then you're going to put the nut on. As you can see, the spring is about the same length as the screw itself. So that's an ideal guide as to how long the spring has got to be cut down to. And then we need to wind the nut on so that it's just flush with the screw. The one that's at 6 o'clock we need to do the same thing with. Okay, now if you grab hold of these two holes opposite the springs, you should find the whole thing will flex up and down, and you've got a nice little sort of bouncy compression flexi system. There's your other two M4 nuts, and put those behind there. There is a cavity behind there to take the nut. Hold it in the cavity and put your screw through from the front. Okay, so hopefully we've now got a nicely little gimbaled LED pointer. Now I'm just going to go with my soldering iron and attach some extension leads to these. Here we've got a cheap battery box with a couple of AA batteries in it with a switch on it. So it's a nice convenient portable tool. You could buy these as a 5-volt diode, and you could probably hook it up to your USB system somewhere, but I thought that the 3-volt version would work better with a battery box. Well, here I am at about 1.5 meters away from the wall where I'm projecting this onto, and I've got a spot there that is about probably 4 millimeters diameter. As I close in to what, 6 inches, it might have dropped to 3 millimeters. It's not changing significantly. The flare pattern or the interference pattern around the outside is changing, but the actual dot itself is not changing. Let's see where it goes and what we're going to be able to do with it. Right here, so we're going to be able to drop that in there like that. Make sure our nuts are pulled back into the slots. There we go. That should be flat back on the front face of the water jacket. Now we can turn it on. And you may remember in one of our earlier sessions now that we made this as our first project. And this is a little target holder. If we open up the side door of the machine, our little target holder sits on top of that mirror plate there. Make sure it sits tight against the plate at the bottom so that it's sitting back nice and flat. There's the beam lined up on centre one way, and now I'm adjusting the screws to line it up on centre the other way. Now move that one out the way, or we can leave that in place and just remove the target, because the beam is designed to pass through there, so we could leave that in place like that. And here we have the other target holder that you made, and that fits snugly over this mirror number 3, fits snugly back against it, and we can hook the target in the top there, and we can see how we're lined up on that one. So that immediately tells me that there's some sort of problem with the alignment of the mirrors on this machine, which I'm going to have to look at sooner rather than later. So maybe that will be the next session now that we've got this tool. I could tweak that up to come into the right place, because the fact that I've set it correct on mirror number 2, so that's now more or less correct at mirror number 3 at the extremity of the beam path. Let's just go back and check what it is at mirror number 2. Well, that's what mirror number 2 looks like. It's a bit high, but it's still hitting the mirror because it's still within one target ring. And we'll talk about what those rings mean in the next session. Thank you very much for your time again. I hope this has been an interesting one. I think it's going to be even more interesting in the next session, actually.